All right, let's talk about something that's quietly running the internet's security behind the scenes. We're diving deep into the tech that powers pretty much every modern secure login you use, JSON Web Tokens, or as you'll usually hear them called, JWTs. They are the unsung heroes of today's web, so let's really get into what makes them tick. So, to really get why JWTs are such a big deal, we gotta look at the problem they solve. Old school logins, the kind that rely on a server remembering you with a session, well, they really start to fall apart in the modern world. I mean, think about it. Today's apps are split into tons of microservices. We've got mobile clients, single-page web apps. Trying to keep a single session alive and consistent across all that is just a massive headache. It just doesn't scale. And this is exactly where JWTs come in. They offer this, revolutionary idea called a stateless approach. Instead of the server needing to keep a log of your session, all that info is packed right inside the token itself. The server doesn't have to remember you at all between requests. Yeah, this slide lays it out perfectly. On the left, you've got the old, stateful way. The server has to hold on to every single user's session data, which eats up memory and makes it really hard to grow. But on the right, you've got the JWT approach, stateless. All the info the server needs is right there in the token. This is an absolute dream for distributed systems like microservices, because any service can look at the token and verify it on its own. No need to call back to some central memory bank. And honestly, this stateless design is what makes JWTs a total game changer. They are incredibly scalable because you're not bogging down your servers with all that session data. They're a perfect match for microservices. Each service can just validate a user on its own. It also unlocks really powerful features like single sign-on, or SSO, where one login gives you a token that can work across a whole suite of applications. And for mobile apps and modern web front ends, where cookies can be a real pain, they just work beautifully. So what's actually inside one of these tokens? If you've ever seen one, it just looks like a long, random string of characters, usually broken up by two dots. Well, each of those sections, the X's, the Y's, and the Z's, has a very specific job. Let's crack it open and see what's inside. At its heart, a JWT is basically a self-contained digital passport. It's a standard for securely sending information inside a JSON object that has been cryptographically signed. And the key idea here is that the server doesn't need to go look you up in a database to know who you are and what you can do. The token itself is the proof. So that three-part structure breaks down like this. First, you've got the header. This part lays out the rules of the road, like, hey, this is a JWT. And more importantly, what algorithm was used to sign it. Second is the payload. This is the good stuff, the data, or what we call claims, about the user. Things like their user ID, their role, and a super important expiration date. And finally, the most critical part for security is the signature. This is the cryptographic lock on the passport that proves it's real and that nobody has messed with it. Let's zoom in on that payload for a second. It's made up of these claims, which are really just standardized bits of info. You've got IS, which tells you who issued the token. You've got EXP, the expiration time, which is absolutely non-negotiable for security. Sub is the subject, usually the user's ID. And then you can have custom claims like groups, which is perfect for managing roles like admin or user. Okay, this brings us to the absolute heart of JWT security, the digital signature. I mean, all the data in the header and payload is great, but it's totally worthless if we can't trust it. The signature is how we know for sure that a token is the real deal. And this really is the million-dollar question, right? What stops me from just creating my own token, putting an admin role in the payload, and sending it to your server? The answer, of course, is cryptography. There are basically two main ways to sign a token. First is symmetric signing, like HS256. Think of this like a secret handshake. The server that creates the token and the server that verifies it both know the same single secret key. It's fast, it's simple. The other method is asymmetric signing, like RS256. This is more like a lock and key. You sign the token with a private key that you keep totally secret, but anyone can verify it using a public key, which you can share with the world. This is way more secure for big distributed systems where you don't want to share one secret with every single service. And as you'd expect, there are some performance trade-offs to think about. HMAC algorithms are the speed demons. They're the fastest. RSA is interesting because signing is pretty slow, but verifying is really fast, which can be a good thing in some situations. And then you have algorithms like ECDSA, which give you the same strong security as RSA, but with much smaller keys, which makes them really efficient. But it's not all sunshine and scalability. The very thing that makes JWT so powerful,
the fact that they're stateless also introduces a pretty big catch that we absolutely have to talk about.
Okay, so this is the crucial point. There is no built-in way to revoke a JWT. Once you hand out a token, it is valid until its expiration time. Full stop. If that token gets stolen, an attacker can use it over and over until it expires. Another thing is that the payload is only base 64 encoded, not encrypted. Think of it like writing on a postcard, not sealing it in an envelope. Anyone who gets their hands on the token can easily read what's inside. So never, ever put sensitive data in there. And of course, they can be stolen if you aren't careful about how you store them on the client side. This quote from Stack Overflow just hits the nail on the head. To revoke a token, you'd have to keep a list of bad tokens somewhere on the server. But wait a minute, if we're keeping a list on the server, aren't we just reintroducing state? It seems to defeat the whole purpose of using stateless JWTs in the first place. It's a real catch-22. So how do we get out of this mess? Well, the most common solution is a really pragmatic one: the token blacklist. Here's how it works. When a user logs out, or maybe an admin realizes a token has been compromised, the server takes a unique ID from that token and adds it to a blacklist. This list is usually stored in a super fast in-memory database like Redis. Then, for every single request that comes in, the very first thing the server does, before it even bothers checking the signature, is do a quick lookup on this blacklist. If the token's ID is on the list, it's rejected immediately. And to keep this list from growing forever, you just set the blacklist entry to expire at the exact same time the original token was supposed to. Pretty clever. So really, what we're doing here is making a conscious trade-off. We're giving up on being purely stateless by adding this blacklist, but in return, we get to plug a massive security hole. It's a tiny, manageable bit of state that gives us a huge security win. All right, let's wrap this up by putting it all together with some absolutely essential security best practices you should always follow when you're working with JWTs. First off, always use HTTPS. No excuses. This stops tokens from being snatched out of the air. Keep your token expiration times short. I'm talking minutes, not hours or days. If you need longer sessions, use a system with refresh tokens. To protect against common web attacks, store your JWTs in secure HTTP-only cookies, which prevents JavaScript from being able to access them. And finally, and this is a big one, never ever trust the algorithm, ALG, specified in the token's header. An attacker can change that. Always enforce the strong algorithm you chose on your server. And that leaves us with one final fascinating question. If we have to add a stateful blacklist to solve the revocation problem, have we just come full circle and reinvented the traditional session? This is a really hot debate. Some developers argue it completely negates the main benefit of JWTs, while others see it as a necessary, smart compromise for real-world security. It's a great question that gets right to the heart of making architectural trade-offs, something to think about. Thanks for tuning in.